Welcome back, business calculus students. This is Mrs. Cornell. In this part of our midterm review videos, we're going to be working problems 13 through 19. We'll be dealing with finding derivatives using rules of differentiation. So we'll cover the power rule, the product rule, the quotient rule, and the chain rule. We're going to be working with algebraic functions in this section. So let's get started with problem number 13. Use rules of differentiation to find the derivative and then simplify as far as possible. On problem 13, we're going to differentiate term by term. So on the first term, we have a constant multiple 7, which always filters through to the derivative, and we're going to apply the power rule to x squared. So we bring the power down in front, we keep the base the same, and we decrease the exponent by 1. Previously it was 2, now it has an exponent of 1. On the second term, when we differentiate negative 6x, we bring the constant through to the derivative. And then if we apply the power rule to x, if we have x to the first power and we want to differentiate it, we bring the power down in front and then we decrease the power by 1. So we end up with 1 times x to the 0th, and we know that x to the 0th is equal to 1. So really, whenever you have a linear term like that, the x just disappears. So the derivative of negative 6x is negative 6. On the third term, we write down the coefficient. We apply the power rule to x to the negative 2. So we bring the power down in front, base stays the same, and then we decrease the exponent by 1. Our differentiation process is complete. Next, we need to simplify. So 7 times 2 gives us 14, minus 6, negative 6 times negative 2 is positive 12, and x to the negative 3 stays the same. So our derivative is 14x minus 6 plus 12x to the negative 3. That's a pretty simple example. On question 14, we're going to again be applying the power rule to these terms, but first we're going to rewrite the equation in a different form. We're going to write it in such a way that makes it easy to apply the power rule. So I'm going to take all of those x's out of the denominator and give them negative exponents. Now notice I'm not differentiating, I'm just rewriting the function. So it's still y, not y prime. The first term can be written as 6x to the negative 5th. The second one, negative 8x to the negative 4th. 2x to the negative 1 for the third term, and square root of 3, no change there. Now we're ready to differentiate. I'm going to denote this as y prime. Applying the power rule, term by term, we have constant multiplier 6 times derivative of x to the negative 5th, which would be negative 5x to the negative 6th. Next term, we have constant multiplier negative 8. Applying the power rule to x to the negative 4th, we end up with negative 4x to the negative 5th. Remember, because we subtract 1 from the exponent. Next term, we have constant multiplier 2. Applying the power rule yet again, we have negative 1 times x to the negative 2. The derivative of square root of 3 is simply 0 because the derivative of a constant is is 0. Now, let's simplify our derivative on the next step. We're really just going to go through and multiply those coefficients. So 6 times negative 5 gives us negative 30, x to the negative 6th. Next term, negative 8 times negative 4 is positive 32, x to the negative 5th. Third term, we have negative 2, x to the negative 2, and we'll just leave that 0 alone. Now, should you report this answer on your midterm exam, I would give you full credit for that. However, it's a good practice to always strive to put your answer in the same format that the original function was presented in. In my answer currently, I have negative exponents, but in the original presentation of the function, we had fraction form. So I'm going to go back and put each of these terms in fraction form when I report my answer. Notice in this first term that exponent negative 6 only applies to the x. So that's the only part that's going to move into the denominator. The negative 30 stays in place in the numerator position. So negative 30 x to the negative 6 can be written negative 30 over x to the 6th. Same thing for the second term. I'm going to apply this exponent negative 5 only to the x. The 32 is going to stay where it is in the numerator position. So we end up with 32 over x to the 5th. Last term, being careful to apply this exponent negative 2 only to the x, we can rewrite that term as negative 2 over x squared. So 13 and 14 are pretty straightforward differentiation problems. We're applying the power rule term by term. Starting with problem 15, we're going to have to face the product and quotient rules. So product rule on number 15, quotient rule on number 16. Make sure you have those patterns memorized for your midterm exam. So before we actually calculate the derivatives, let's map out our plan according to the product rule. So when we find the derivative, y prime, we're going to take our first function, 2x squared plus 5, and we're going to multiply it by the derivative of the second. We'll denote that as 5x minus 4 prime, plus the derivative of the first function, 2x squared plus 5 prime, times the second function as is. I like to remember the product rule as same times derivative plus derivative times same. And in this manner, I always keep those factors in the same order and just alternate keeping the term the same and multiplying by its derivative. So again, that pattern is same times derivative plus derivative times same. Now that we have our plan mapped out, let's go back and execute those derivatives. So the first factor, 2x squared plus 5, stays the same, and we calculate the derivative of 5x minus 4. The derivative of 5x is 5. The derivative of negative 4 is 0. So the derivative of that entire term there is just 5. Don't forget the plus in between these two terms. The derivative of 2x squared is 2 times 2x, or 4x. Notice we keep the constant multiplier 2, and we apply the power rule to x squared to get 2x, and therefore we end up with the derivative 4x. Now, the derivative of the plus 5 is 0. So that derivative term is complete. And then we keep the 5x minus 4 the same. At this point, the differentiation process is complete. That is, the calculus part is done. Now we need to work on simplifying our answer. And we're just going to be applying our rules of algebra. So let's begin by breaking up these parentheses using our distributive property. We have 5 times 2x squared, which is 10x squared, 5 times 5, which is 25. Again, applying the distributive property to this second term, we can distribute 4x and obtain 20x squared minus 16x. All we lack here is to combine like terms. And we'll want to start with the highest powered term and go in descending order. So we have 10x squared plus 20x squared. Those are like terms. They combine to give us 30x squared. The next highest term would be the x to the power of 1, or negative 16x term, and then finally our constant term there, plus 25. So our simplified derivative is 30x squared minus 16x plus 25. Keep in mind, when you take your midterm, I will be grading your work. So show all of your work, and I do award partial credit. So if you make it this far, you get partial credit for applying the calculus right, for executing the product rule. Full credit comes for complete simplification. So after you differentiate, then you simplify, you get full credit for that. Okay? So that's the product rule. Make sure you practice plenty of those. You'll see that on the midterm exam. On problem 16, we're going to differentiate with the quotient rule because the original function is a quotient. So as we did with our product rule, let's map out our plan before we execute the derivative. When we differentiate a quotient, I always like to start in the denominator. We're going to square the original denominator. Now, when you start with that term, it reminds you the correct term to start with in the numerator. And then we're going to follow that pattern, same derivative, derivative, same. So the denominator that I just squared is going to be the leading term of my numerator. Then I'm going to multiply by the derivative of the original numerator. Now pay attention, in the quotient rule, we have a minus in between the two terms. Whereas in our product rule, recall, we had a plus in between the two terms. Now, in the quotient rule, it matters the order in which you get your factors because of that minus. Again, that's why I said, if you remember, square the denominator first and start with that term and follow the pattern, same derivative, derivative, same, you'll have everything in the right order. So continuing to map out our quotient rule here, we have the denominator times the derivative of the numerator minus. The next step is to find the derivative of your original denominator times the numerator as is. Okay, so this is the plan. You don't have to show that part every time. You can go directly to the next step where we're actually executing those derivatives. Now, don't be lazy. Write that denominator every time. You don't want to leave it behind and accidentally forget to include it in your answer. So executing our derivatives, we have x squared plus 8. The derivative of 5x plus 7 is 5. There's a minus in between. The derivative of x squared plus 8 is 2x. Remember, the derivative of a constant is 0 times 5x plus 7. The calculus part is done. We have successfully evaluated the quotient rule. Now we want to simplify. That part requires algebra. So in the numerator, let's use our distributive property here and here. And this will break up our parentheses. So y prime then would be 5x squared plus 40. Don't forget to distribute negative 2x here. Be careful of the sign. Minus 10x squared minus 14x, all divided by denominator squared. Don't worry about multiplying out the denominator. Leave it in factored form. That way, in case you have the potential to reduce it with some factor in the numerator, it will be ready to go. So again, leave that in factored form. Let's combine like terms on the top. Starting with our x squared terms, we have 5x squared minus 10x squared. That combines to give me minus 5x squared. Next term will be our linear term, or minus 14x, and then plus constant term 40, divided by good old denominator squared. Now I'm going to inspect the numerator to see if I could potentially factor it. And in this case, what I'm really looking for is x squared plus 8 a factor of the numerator? If so, I want to go ahead and factor and reduce it. But because I can tell that x squared plus 8 is not a factor of the numerator, it's not going to reduce any. So we are good to go. Our official answer, negative 5x squared minus 14x plus 40 divided by x squared plus 8. If you can't show all that work in the space provided, feel free to just put an arrow that your work is on the back side of the sheet. I'll be able to find it, no problem. So that is the product and quotient rule practice problems. Let's work on our chain rule. On problem number 17, we will be applying a combination of the chain rule and the power rule. So notice right here I have not just x to a power, but a function of x to a power. That's how I know to apply the chain rule. So when we differentiate, we're going to do so as normal, but we're going to have an extra factor coming out of the chain rule. So I'm going to pretend for a minute that I'm just applying the power rule. If I have negative 3 times something to the negative 6 power, I would filter that coefficient, negative 3, into the derivative, and then I'd apply the power rule to the next factor. The power rule says take the exponent down in front. For now, I'm going to keep the base the same, and then decrease the exponent by 1. But because that base is something other than just ordinary x, the chain rule says I have to multiply by the derivative of that base, like a link in a chain. The derivative of just the base, 4x squared plus 3, is 8x. So we applied the power rule, and we have this extra chain link because, again, that base is something different from x. Simple as that. We are ready to simplify. When we simplify, I'm just going to collect these little factors here, multiply them all together, and put them on the left side. So we have negative 3 times negative 6, which is negative 18. And then 18 times 8x gives us 144x. Notice it's positive. And then don't forget about this little term here. And that accounts for everything. So we have 144x times 4x squared plus 3 to the negative 7 for our derivative. Okay? Sneak a y prime equals out there. So we've practiced the product rule, the quotient rule, and the chain. On the next problem, we're going to be applying a combination of those rules. So notice on problem 18, we're going to need both the product and the chain rules. The product rule, because I can see that this function is composed as the product of two functions. So we'll definitely plan out our product rule. But we're also going to need the chain rule because we have functions of x raised to a power in each case. So all of that will come into play in our derivative. So applying the product rule, remembering the pattern, same times derivative plus derivative times same, we're going to begin with keeping that first factor, 5x plus 2 to the fifth, the same. So we have the first factor kept the same times the derivative of our second factor. Now the second factor is going to require the chain rule in order to differentiate it. So we bring our power, negative 4, down in front. We keep the base the same on this step. Don't be tempted to differentiate right there. Be patient and wait for it. And then decrease the exponent by 1. Now we're not quite finished. Now we're ready to find the derivative of that base, which is 4. So there's the chain rule part in this problem. So we have the first function kept the same times the derivative of the second, where we had to use the chain rule there, plus the derivative of the first function. Now, applying our chain rule now to this first function, we're going to take our exponent 5 down in front as a coefficient. Being very patient here, we're going to keep the base the same, 5x plus 2, and decrease the exponent by 1. So we're basically differentiating the outside part there. Now we're ready to differentiate the inside part. The derivative of 5x plus 2, of course, is just 5. We've got one more factor. Remember, we're following the pattern same times derivative plus derivative times same. So now we're going to take that second factor, keep it the same, and tack it there on the end. All right, so the calculus part is done. The next part is really what the hard part is, and that is the algebra. So we need to attempt to simplify this. Now, don't panic. We're not going to multiply all that stuff out. Our goal is to factor it. If we can put it in factored form, we're going to be in good shape. Observe here, we really have two terms. We've got the term to the left of the plus and the term to the right of the plus. So before I go any further, I just want to simplify each of my terms by collecting all of those little monomial factors. So on this term, I'm going to take the negative 4 and the 4 and multiply those together to get negative 16. Then I'm going to have my bigger factors on the right side. Just makes it a little easier to read, so I can kind of tell what I'm dealing with here. For the second term, again, I'm going to take those little monomial factors, 5 times 5, call that a 25, and move it to the left. And then put the bigger, more complicated terms here on the right side. Now again, remembering that I only have two terms here, I am looking for what these two terms have in common. So I spot both of them having a 5x plus 2 in common and a 4x plus 1. When we factor, and by the way, we're just taking out a greatest common factor here, I'm going to take out the lowest power of those common factors. So I can tell again that both of them have a 5x plus 2. This is my greatest common factor between those two terms. I'm going to write the GCF in red. I'm going to take out the lowest power that's in common. On the next term that they have in common, 4x plus 1 and 4x plus 1, we're going to take out the lowest power. Now, that translates into taking out the biggest negative. That's really the smallest number there. So this is the greatest common factor between those two terms. Okay, so we take the greatest common factor out to the left, and then we're going to divide each of those two terms by the greatest common factor and see what's left behind. So in brackets here, I should anticipate two terms to represent the original two terms. So inspecting our first term, I have to figure out what can I multiply this greatest common factor by in order to produce that first term. Well, I notice my GCF does not have a negative 16, so I know I'm going to need a negative 16 here. Okay, comparing our GCF to this first term again, notice I have a 5x plus 2 to the 5th, and in my GCF I only have 5x plus 2 to the 4th. So I know I'm going to need another 5x plus 2. That way I'll have a total of 5 of those. Comparing my GCF to this last factor, it matches identically, so I don't need to include any more information in this first term. Okay, now you can check to make sure that's factored correctly by distributing. If I take my GCF and I multiply by this blue term here, I'm going to obtain that original first term. Okay, so we have successfully removed the greatest common factor from that first term there. Let's do the same thing for our second term. So now I'm going to be looking at taking the greatest common factor out of this term. Well, my GCF does not have a 25, so I'm going to need to include that here. Looking at the 5x plus 2, the GCF has that term raised to the 4th power, which matches our second term exactly. So I'm not going to need that factor 5x plus 2 here. But we do need to look at this term. We have 4x plus 1 raised to the negative 4th, and our GCF has it raised to the negative 5th. So remembering that when you multiply like bases, you add the exponent. I'm going to need 4x plus 1 to the 1st power. Now, I can hear you saying, what just happened, Miss Cornell? What did you just do? Remember, when you multiply like bases, you add the exponents. So if I'm just looking at multiplying this part by this part, those are like bases, right? 4x plus 1 matches. Then I'm going to add the exponents. Negative 5 plus 1 gives me negative 4. Okay? So it is successfully factored. The only thing we lack here is to simplify that term in brackets. And we're going to do that with a little bit of distributive property. Okay? So let's copy down our GCF. It's simplified. It's good to go. I'm going to demote these brackets to parentheses here, and I'm going to apply the distributive property to these two sets of binomials. So we have negative 16 times 5x, which gives me negative 80x. We have negative 16 times 2, which is negative 32. 25 times 4, that gives me 100x. And 25 times 1 gives me 25. So here's the point. Like I said, if you need to attach notebook paper or flip over and work this on the back side, feel free to do so. Working on this last parenthetical element, we need to combine like terms, and I think we'll be home free. So combining like terms, we have negative 80x plus 100x. That's going to combine to give me 20x. And then we have negative 32 plus 25. That gives me a negative 7. All right? So what was the hard part, the calculus or the algebra? Definitely the algebra, right? That's going to take some practice. Do practice that a couple of times. Anticipate having one of those on your midterm. All right, so don't be surprised when you see that on your midterm. Be prepared and well practiced. So let me officially report my answer over here. We have 5x plus 2 to the 4th power, 4x plus 1 to the negative 5th power, times 20x minus 7. Okay? So remember, that first step we were done with the calculus. Everything else was algebra. Okay, one more problem for this particular video, number 19. We're going to look at applying a combination of the quotient rule and the chain rule together. And I can already tell I'm not going to have enough space to work this right here, so I'm going to get some additional board space. Again, feel free to attach notebook paper or work this on the back side of your review. So our function here is y equals t squared plus 4. Uh-oh, we switched our x to a t. I don't want to irritate you, because we're going to have to deal with the t quite a bit. Okay? So let's begin differentiating this quotient with the quotient rule. And let's follow our good practice of squaring our denominator first. So we have 8t minus 6 to the 18th power. Remember, when you raise a power to another power, you multiply those powers. So when I'm squaring something raised to the 9th power, I multiply 9 times 2 to get 18. Then I'm going to lead with that term in the numerator. Now, I'm leading with the original term, not the squared term. So I have denominator times derivative of the numerator. The derivative of the numerator is 2t, okay, minus derivative of the denominator. Now here's the part where we're going to have to apply the chain rule, because notice when I differentiate the denominator, it's a function of t raised to the 9th power. So I'm going to begin with the power rule. That is, I'm going to bring the exponent down in front. I'm going to be really patient to keep the base the same here while I decrease the exponent by 1. Then, according to the chain rule, I'm going to multiply by the derivative of that base. Now, don't forget, we're following the pattern same times derivative plus or minus derivative times same. So I still need to put my numerator in its original form out here. Okay? Check calculus off your list. We are done with the calculus part. The next part is simplifying. Now, our goal is to see if we can factor that numerator and possibly reduce a factor in the numerator with all of those factors in the denominator. Okay, so here we go. I'm going to leave this denominator alone for a little bit. And notice in the numerator, we have two terms, one on the left of the minus, one on the right of the minus. I'm going to inspect those two terms to figure out what they have in common. Now, before I do that, maybe it would be easier if we clean it up a little bit, right? Let's take our little monomial factors to the left. So we have 2t times 8t minus 6 to the 9th. And over here, we can multiply the 9 times 8 to get 72. We have 8t minus 6 to the 8th. And t squared plus 4. A little easier to look at now, and I can figure out what they have in common. So comparing the term on the left of that big minus to the right, I can see they have a factor of 2 in common. So let's take that out as part of our GCF. And they have this 8t minus 6 in common. We're going to take out the lowest common power here, which would be 8th power. Okay, so that's the GCF. We've extracted it. We're expressing it here on the left side. Now we need to divide each of those two original terms by this GCF, figure out what the reduced term is. So comparing our greatest common factor here in red to the first term on the left side of the minus here, I can see the 2 is already represented in the GCF. But notice I don't have this t in my GCF, so I'm going to need a t for this term. In the greatest common factor, I have 8t minus 6 to the 8th power, but to fully represent this term, I have to have the 9th power. So we're going to need one more of these guys in order to make up that whole term. So again, check by multiplication. If I multiply these two terms together, I'm going to get 2t times 8t minus 6 to the 9th power. Copy down that minus, and let's inspect our second term. Our second term here, we're going to need a 72. I've already factored out a 2 as part of the GCF. So 72 divided by 2 is what? 36? I have 8t minus 6 to the 8th power represented in the GCF. That matches what's there in the second term. So I'm not going to need an 8t minus 6 factor in this term. But I will need one more thing. That is t squared plus 4. Okay? So the GCF has been successfully factored out. And let's not forget about this little guy in the denominator. Now, it's a good thing we factored it. Observe here we have three factors, the 2, the red 8t minus 6 to the 8th, and then that big thing in brackets. We're going to need to simplify or combine like terms to the bracketed element. Before we do that, though, let's reduce. 8t minus 6 to the 8th power cancels here and leaves a factor of 10 or a power of 10 in the bottom. Remember, we're subtracting the exponents when we divide like basis. So 18 minus 8 leaves us 10 in the denominator. Okay, let's assess what we have here. We have the 2. The 18 minus 6 to the 8th has canceled out. I'm going to demote those brackets to parentheses and work on simplifying what's inside brackets here. So when we distribute the t here, we have 8t squared minus 6t. When we distribute the negative 36 here, we have negative 36t squared minus what? I better multiply this right while I'm on video, right? I'm going to pop over and double check with my calculator. We get 144. So we have 36t squared minus 144. Okay? Divided by 8t minus 6 to the 10th power. Okay, let's combine like terms in our parenthetical element in the top. 8t squared minus 36t squared gives us, let's see, negative 28t squared. Then we have our linear term followed by the constant term. So far, so good? Now, if we want to express it as we have there in the answer sheet, we can simply distribute that 2, and it will match perfectly. That would give us a negative 56t squared minus 12t minus 288. Okay, so that matches the answer. Now, if you are an algebra fanatic, which I know you are, there's our derivative, you can tell that's not quite reduced, right? So let me take you through a little bit of further simplification, just because it's bothering me in this unreduced form. So I'm going to go back to this step right here. Okay, instead of multiplying out the 2 as it matches the answer that's provided in your answer list, let's reduce it a little bit further. Okay, notice in the numerator in that parenthetical element, we have a common factor of 2. So, and in fact, let's take out a negative 2. So here's the 2 from the original problem. Here's the negative 2 that I'm extracting from this parenthetical element. Dividing each of those by negative 2, we would have 14t squared plus 3t plus, what's that, 72. Okay, and in the denominator, did you notice that the 8 and the 6 have a 2 in common? We're going to factor out a 2. So I'm going to take a 2 out of the denominator. That leaves behind 4t minus 3. we do have to be careful to raise that whole thing to the 10th power. Okay? Now, looking at the 2's in the numerator and the denominator. I'm going to leave it, actually let's multiply that together. Negative 4 times 14t squared plus 3t plus 72. And then notice here you've got 2 factors raised to a power, so each factor should receive that power. Okay? And then, aren't you glad we did that? Because now we've got a couple of even numbers here that we could reduce. Negative 4 over 2 to the 10th power. Let's see if our calculator will be of any help in simplifying that number. Whoops. Negative 4 divided by 2 to the 10th power. Turn it back into a fraction. Negative 1 over 256. So our completely simplified fraction here would be negative, parentheses 14t squared plus 3t plus 72 divided by 256, 4t minus 3 to the 10th. All right, so that's our completely reduced answer, which is really the best answer. All right, so this was a tough portion of the review, so spend some time practicing these problems. Feel free to go back and listen to these problems over and over until you feel confident that you have them figured out. All right, thanks for listening.